Okay, hi everybody. My name is Professor Mustafa El Melodi. You can call me Prof E. Um, I'm going to be your instructor for the Programming Fundamentals 1 class. I've been teaching for 22 years. I taught a variety of courses: computer science, business computer information systems, um, and some business courses, different levels of computer science, uh, mobile applications, and a few other courses. So as you can see, this is the first class, Programming Fundamentals 1. So as the name implies, we'll be covering the main concepts of programming. So whether you have a background in programming or this is your first time, you should be okay, because we're going to start from the basics. Okay, let me go very quick over the syllabus. If you have any questions about any aspect of it, please let me know. So as you can see, this is online. That means the materials are online. The assignments will be done online. The programs will be online, and the final exam as well. Now for the final exam, I will assign a specific day or 2 days, and then you have to take it, in one of these 2 days. Of course, the final week of the semester. Okay. So this is the objectives, as you can see right here. So, of course, we are using Java as programming language. And then we'll be covering the main concepts like data types, conditional statements, loops and iterations, arrays, basically object-oriented concepts. So let me go over the main thing, this is basically the grading breakdown. As you can see, we have discussion participation 10%, and then we have quizzes 15%, programming assignment to show you the significance of these programs. It's 20% of the final grade. Projects, I think we have one or maybe two, I think at least one project. So basically, a project is kind of a comprehensive program that check the understanding of the main concepts, and then we have, of course, the midterm and the final exam. And then finally, I'm going to go through the calendar. So all this information, as I said, if you have any questions about any aspect, let me know. So the calendar, as you can see, it shows the topic covered every week. So we're going to start today chapter 1, and then introduction to computers and programming. Okay, I'm assuming you already did introduce yourself discussion, so please make sure you answer these basic questions, and then also Canvas quiz to make sure that you are familiar with Canvas. So the midterm, as I say, is going to be February the 26th, or that week. I'm sorry, this is the midterm review. Midterm exam is on the first week of March. And then we have the spring break after that. Okay, so we'll be covering basically seven chapters. And the final exam is on May the 8th. Okay. All right, so now let's get started with chapter 1. So the best way in Canvas to look at the topics is basically go into modules. That's the best way, to find what you are looking for. So as you can see here, we have discussion. That's basic information about yourself. And this is Canvas quiz. So it should be an easy easy quiz. Now this is very basically for practice. You should be able, if you click on first day inclusive, that should give you access to the course materials. And Reveal basically is an online, where you find the online practice and exercises and assignments. So this will be graded for completion grade. That means you just try your best. So whatever you do is going to show on the grade book. So just make sure you try your best because it's for completion grade, not for accuracy. So just to help you practice and get better, because computer science, just like math, you need practice. All right. So this is chapter 1. As you can see, there is 2 parts: the study materials. I put the PowerPoint, I put videos that I record, anything that helps you with the concept, I put it under study materials. And then we have assignments. Of course, you have to program an assignment where you practice what you learned, and of course a quiz, multiple choice questions about that specific topic. Okay, so let's start with chapter 1. So as you can see right here, chapter 1 is an introduction to computers, programs, and Java. So this is the objectives, as you can see, to understand the computer basics, basically how the computer works, the main components of the computer system, and then the input devices, the output devices, basic syntax Java program, and how to create a first program. So what is a computer? A computer consists of, so this is basically the simplistic definition of computer. So it consists of CPU. So CPU basically is the brain of the computer. So this is where the execution is taking place. And memory. Of course, memory, the information, the data has to be saved, because if it's not saved, it cannot be executed. So it has to be saved in a memory. And then, of course, the memory basically is a temporary storage of information. It's not a long term. That means once the light is turned off or disconnected, then all the information are lost. That's why we need some kind of permanent storage or permanent memory, like the hard disk and any other, like floppy disk. I don't think people use floppy disk anymore. But anyway, some long-term storage. The monitor allows you to display the information, printer, and communication devices to connect the computers. So this is like a basic diagram of how the computer is made. So made of the CPU, memory. So there is the data keeps going back and forth between the CPU and the memory. So the CPU asks for the information, okay? And then, of course, the bus is for transportation, as the name implies. It allows the transfer of information and data between the components, okay, from CPU to memory, from memory to CPU, to external devices, and so on. So all these components, they work together. And then finally, we put the information in storage devices, okay? Input device, we'll talk about this. The input devices basically is any device that allows you to get the information inside the computer, like keyboard, like mouse, like scanner. And output devices are the devices that that allows you to get the information out of the computer after processing, like printer, like monitor, like a speaker. So speaker get basically the voice out. So as we said, the CPU basically is the main part of the computer. It's like the brain of the computer. That's where the arithmetic operation, all the computation take place. And of course, you have to make sure that all the instructions are done in a smooth way, in a consistent way. That's why you need a few other components, like, for example, the clock. make sure that the clock allows the synchronization of statement. That means make sure that everything is happening or is taking place in the right order. Otherwise, there will be kind of ambiguity or lack of clarity. Memory. So memory is a very, very important component. That's why when we go to the, to Best Buy or any computer store to buy a computer or laptop, the first thing that you ask or you pay attention to is memory, because generally speaking, the more space you have in a memory, the better, the faster the computer is. It's just as easy as that. Of course, there are other factors, but generally speaking, the more space, the more capacity you have in the memory, the faster the computer is. Okay? So we have different types of memory. We have what we call RAM, random access memory. So that's basically where you get the information first, temporarily. And then the CPU will ask for the information, okay? And then we get the information from RAM, it will be processed in the CPU, and then it will be returned to RAM, and then from there to other devices, to external devices as output. Okay, so that's the memory. Of course, here in this class, we're just mentioning this like in briefly, because otherwise, if you want to go in detail about every single aspect, you need to probably to take a computer organization architecture class, because they go like in detail, like every single part of this. So that's not the purpose. That's outside the scope of this class. So we're just trying to, kind of explain very briefly what the computer is all about. So how the data is stored. So everybody knows that the only language the computer understands is a machine language, basically a bunch of zeros and ones. That's the only, anything and everything needs to be converted to a machine language, okay? Otherwise, like basically when two people speak two different languages. So we humans, we speak a language, let's say for example, in terms of numbers. So the only number system we understand is the decimal, like from 1 to 9, from 0 to 9, right? So that's the human language. Now the computer does not understand the decimal language, so it has to be converted to binary, which is made of zeros and one. So anything like letters, numbers, text, video, audio, you name it, everything needs to be converted to a machine language for the computer to understand and respond. So the storage devices are for long-term memory. So when you want to save something for permanently, so you can use flash drive, or you can use hard disk, or any other way for permanent storage. The monitor, of course, is for displaying the information. And then, of course, the resolution decides how the quality of the screen, okay? So that's why you need to pay attention to the pixels, okay? Because the screen resolution basically specifies and determines the quality of the image. The communication devices, of course, like when you use the computer, most of the time, you are not using the computer in like isolated. It has to be connected to other computers, either as a small network, like for example, in a building or an office, you have computers connect to each other so they can share resources, they can share files, they can share printers, they can share all kinds of resources or data, or at the highest level like internet. Because what is internet? Internet is just a worldwide network. All the computers are connected with each other. A program. Now we get to the program. What is a program or software? Computer programs, known as software, are instructions. So program is a set of instructions that the computer can understand and execute. Okay? So basically, if you want to tell the computer what to do, it has to be like, first we and then we're going to talk about this later on. So we use a high-level language like Java, C++. So that's basically the closer we can get to the human language is the high-level language, okay? Like when you type a code in Python or C++ or Java. So this is the highest level you can get. Of course, the computer does not understand this language. That's why there are different levels. There's a high-level language. That's the closest to the human language. And then below you have assembly language. Assembly is like in the middle. It's between the human language, the high level, and between the machine language. And there is something even below the machine language. That's basically a hardware level. Okay, so there are different levels. Of course, the lower the level, the closer to the machine language, to the language that the computer understands, and the higher you get, the closer you get to the human language. Okay, so that's what I was talking about. So we have high level language, we have assembly language, which is combination. There are some few, what they call them mnemonics. So basically few words that mean something, but they're very limited. Like English terms or English words are very limited. Most of them are symbols. Machine language basically just a bunch of zeros and ones in a certain order. So this is an example of like how to convert from one level to the other or from one language to the other. So as I mentioned, so this is just basically briefly speaking, but if you want to get kind of deeper, there are classes like assembly language class or computer composition architecture class. You get into very detail. So this is an example of an instruction at the highest level, higher level. So you have area, that's in English, you can understand, and then you multiply the radius by itself, and then, so to calculate the area of a circle. Now, of course, the machine language will be different than this. So this is the popular high-level languages. So C++, COBOL, so there is many of them. Of course, like the concepts are the same, but the syntax are different. And then I always get this question from my students, what is the best programming language? And my answer is always the same. It depends. It depends what you're going to use it for. So for example, if you are into data science, I would say probably Python, the R language are the best. If you are talking about website design, I would say Java probably is one of the best languages. If for you, video games, so probably C++ is one of the languages you may want to consider. So it depends what you're going to use it for. There is no single language that is very good and excellent in every aspect. Okay, there are always pros and cons. All right, interpreting and compiling the source code. So once you type the code, it has to go through a process. Okay, so we start from the source program, the source code, and it has to be interpreted, it has to be compiled, check for errors, change it to something that the computer can understand until you get to the machine language. So this process called the compilation interpretation. So this is an example how it works. Okay, from the source code until you get the information as an output. Operating system. So there's a difference between operating system and application system. So operating systems is like the Windows, Linux. So it's a program that manage and control the computer's activities. Basically, it's like intermediation between us humans and the machine language. That's basically control the basic things that the computer can do. But the application system is a software that is for a specific reason. Like, for example, if I say Microsoft Word or Excel or PowerPoint or Access, these are only for a specific reason. So I'm going to use PowerPoint only for presentation purposes. I'm going to use Access only for database purposes. I'm going to use Excel for spreadsheet, for example. I'm going to use Microsoft Word only for word processing and so on. So there is a reason, there is a specific task. Now, this is the question that probably we need to start with why specifically Java? Why not other language? What makes Java unique? Of course, as I said, every language has pros and cons, but what makes Java unique? So here they're going to mention all the main reasons. So Java enables users to develop and deploy applications on the internet for servers, desktop computers, and so basically it's flexibility and then a lot of characteristics that it has. So Java was invented, you can say invented, or by James Gosling, I think 1995, yes. It used to be owned by Sun System, or I'm sorry, Sun Company, and then it was bought later on by Oracle. So this is the characteristics of Java. What makes Java a unique programming language? So it is simple to use, object-oriented, interpreted, robust, secure, portable. That means you can use it in any type of computer. Performance, dynamic, all these are characteristics of a good programming language. As I said, this is just briefly, we don't have to go like in deep about this. So this is the JDK version. So we're going to get to the IDE. IDE stands for Integrated Development Environment. It's like basically a fancy word for coding platform. That means what is the program we're going to use to code? They call it IDE. So we need JDK. That's basically the Java program that you have to start with before anything else. There are actually a bunch of IDE. Eclipse, NetBeans, the one I use, JCreator. I use Eclipse also. There's a JGrasp. There are a lot of choices in there. All right. So now, okay, I'm going to switch to JCreator. Okay, I already posted a program or video that shows how to install, but it works only with Windows. But feel free to use any IDE you like. So some people, they like Eclipse. I showed I think I posted a video that shows how to create a new Java project in Eclipse. The installation of Eclipse is very simple and straightforward. Now, there are a lot of YouTube videos, even if you don't know, but it's very simple how to do that. And then as I said, my choice is just to use JCreator, but feel free to use any IDE you like. So I'm going to stop here and then switch to just to start the first program. Okay, so let me stop this right here, and then I will switch. Okay, any questions before we move forward? Any questions? Because the first chapter basically is just basics of computer. I mean, it's not that complicated. I don't think you can have anybody will have problems with the quiz or the programming assignments. Any questions? Any comments? Any thoughts? Any ideas? All right, so let me know if you have any questions, okay? So let's switch. I'm going to share my JCreator. So if you open JCreator, it's gonna look like this. And then also I posted how to create a first one, like first Java program. So the best thing to do is to create a folder, an empty folder in desktop or any place, like my documents or anywhere. So this way you can keep track of all your files. Otherwise, it's easy to misplace files. As you can see right here, I'm gonna go File. Okay, first, let me create okay, I'm gonna stop here. Let me create a folder. So I'm gonna go to Desktop, and then I'm gonna create a folder. Let me see here. So I'm just gonna use this. So folder. So I'm gonna call it Java project. So I know that. So it doesn't matter where. I'm just saying that you should know where you're saving your work. Okay, guys, can you see JCreator here? Now, okay, that's good. So I just created an empty folder. That's all what he did. So now I'm going to go File. I'm going to go to New. Very simple. File. And then make sure you are checking or selecting Java classes on the left side. All of this is in a video, okay? The first Java program. And then make sure you click main class, okay? Java classes on the left side. You just have to do it the first time, and after that, it will be the default selection. So I'm gonna go to next. And then here, can you select there is 3 dots next to location? So you click on it so you can specify what is. So in mine, okay, in your case, I don't know. You can save it anywhere, but I created my folder here. I called it Java project. Can you see this? So I called it Java project. And then I'm going to make my first. I'm going to call it my first Java program. Now make sure that you don't leave any space. We'll talk about this later on. When you name your file, there are 4 rules. You can name it anything you want, but keep in mind that there are 4 rules that should never be violated. The first one should never have a space in between. Never have a space in between. Never start with the number. Like don't call it, for example, right here, I cannot start with the number like 5. No. Okay, so make sure you start with the letter and anything, but don't start with the number or the digit. Don't have a space, and don't use any of the keyword that Java uses. We're going to learn about some of the Java terms that has a special meaning. You should never use them. We'll talk about that. And then finally, the 4th one, don't use any special character other than underscore or $sign. So for example, I can put here, underscore, not dash. That's shift. Okay, shift, and then there is underscore in there, yeah, or $sign. So these are the only special characters allowed. Other than that, the other special characters are not allowed. And then you click finish. So that's going to get you this. Now, as for now, we're going to always delete all that stuff here. We'll talk about this later. So delete that. So I'm going to right here and then delete. I'm going to delete here, but be careful that you don't delete something that you are not supposed to delete. All what you have to have, always make sure you have this public class, and this is the name of your program. Make sure it matches with the tab. The file and the class name should match. And make sure, look at the braces. This is the beginning of the program. This is the end. And then this area called the main method, we'll talk about it later. That's basically the execution place. That means any code to be executed, it has to be here, not here. If you put here, it's not going to be executed. If you have it here, it should be here. It should be here. So the code here. Okay, so that's the first thing. So if I click here, this is build the file. So there are 2 steps. Build file, that means check if there are any errors. That's why you see at the bottom right here, it tells me whether I have error or not. So if I click, and of course there is nothing in here, but even if I have nothing, I can check if there is nothing. See, it's going to say process completed. That means there is no error. And then when you click on this button right here, that looks like a play button, this is for running. So let me start with something very basic. Now, just to make it easy for you, if I type out and then wait until you get that little window and hit the enter key, it will type this for me. Or you can type it yourself, but the program will type it automatically. Let me repeat this. So you just type, I'm talking about if you are using JCreator. If you are using something else, then every program has its own features. So for us, we just put out and then wait until you get that little window and hit the enter key. So system out print line, this is L, not number one. Print or print line, basically it will print whatever you have in there at the bottom. So for example, here inside the parentheses, if I put here, this is just a test. And then always end with semicolon. Okay, semicolon basically is just to end any statement, it has to be a semicolon. Now let me do it again, build. So can you see if there is any error? Like for example, let's say I forgot about semicolon here. And then I click on build. Can you see? It's going to say error, semicolon expected. That means like you are forgetting something important. So that's an error. Another error, let's say I didn't close the parentheses. I start, I open the parentheses, but there's no closing. Again, that's an error. So the program, sometimes it will help you. Most of the time, it will tell you what the problem is. Sometimes it will point to the line and you have to figure out what the problem is. There is something in there. So this is an error. Also, another error is maybe you start the quotation, but you didn't close it. That's another error. That's very common. So make sure every opening has a closing. Again, this is opening, close, open, close, open, close, open the parentheses, close. Or let's say you misspelled something, like let's say system, it was lowercase. That's an error. Why? Because it should be uppercase, because it's case sensitive. So all of this, like I would say probably 95% of the errors are misspelling. So just keep in mind that everything has to be spelled correctly. Uppercase S is different than lowercase s. Or I forgot this dots right here. That's very common. So it's going to say error. Or P is uppercase or something like that. Or maybe sometimes I get confused in stuff like L. That's sometimes very hard to catch. If I put 1. Now that's very hard to tell, right? Is it 1 or L? It's supposed to be L, but that's 1. So sometimes it's very hard to find the error. Just have to keep looking. So now look, I build it, I run it. It's whatever I put in here is going to be at the bottom right here. This is just a test. So anything between double quotes, it's called a string. It's called a string. String basically is a text. Another way to say text, anything. Like I can put, for example, here, I can put a statement. Any statement, the program will copy and paste it. Like for example, I'm going to say, this is my first Java program ever. Okay, just to save yourself time, maybe you can just copy. I can copy this. Like, oh, you already know like that. We can just use out. That's easier. Or you can just copy and paste. Hit the enter key, and then I'm gonna say, I am so excited. See that? So when I run the program, it's gonna show this is the first line, this is the second line. Build it, and then run it. See that? Now what happened if I put only print? So when you put only print, the program will not start new line. It will continue. Look, if I run the program, it's going to put, this is my first Java program ever, but it will not start new line. It will continue. Can you see that? I am so excited is in the same line. Why? Because I'm using print. So print will print the statement, but it will stay there. It will not start new line. It will, the cursor will be here, waiting for instructions. So the next statement, which is I am so excited, it will be printed right after ever. So that's the difference. So this, the second print line will affect the next one. So if I put, for example, here, okay, I can't wait to start coding, something like that. So now since I use print line, so it will start new line. So I can't wait to start coding will be in the new line. Can you see it? It's a new line. So that's the only difference. So print will print whatever you have, but stay in the same line, waiting for more instructions, for more instructions to be printed. If you put print line, it will print it and then automatically, it's like you have an enter key. It's like you have an enter key here. That's with print line. So it's gonna print, I am so excited, and automatically hit the enter key. That means waiting for the next instruction. It will be from the next line. So that's the difference between two. There's also another way. Like for example, let's say I'm gonna put, I can't wait to start coding. Let's say start coding, I want it in the next line. There is an easy way. You put \n. So if I put \n, then is another way to say start new line. So \n together will start new line. Let me run the program and show you what happened. Did you see that? Start coding is a new line. That's what \n does. So that's an easy way to start new line, because sometimes you want to finish and you want to start something from next line. So easy way is use, if you don't want to break it down into two statements, so you want to keep it as one statement, so you can just use \n. Okay, or I can put, for example, my name here. Okay, name, okay, Prof E, and then I'm gonna put here something else. Let's say my name, my address, something like that, 224 Sky Boulevard, for example. So now the address will be next line. Can you see that? \n start new line. See that? So that's an easy way to start new line without having another statement which is system out print line. Okay? So that's basically what how you create a program. So now we are learning that you can make a statement like this. We call it string, or you can make a calculation. I can make a calculation. I can put system out print line and then put 5 plus 6. It's like a calculator. So run the program, it's going to give you 11. See that? Or you can multiply. Multiply, we use the asterisk or the star. That's going to give me 30, right? Or you can divide. So 15 divided by 3. So that's going to be 5. Okay. There is something else. I'm not sure if you are familiar with it. It's the percentage. Now, the percentage has nothing to do with the percentage that we learned in middle school. This is basically the remainder. So, for example, if I put 4 here, when you divide 15 by 4, the answer is 3, right? 3 times 4 is 12. What is the leftover? Anybody? The leftover. Okay, go ahead. 3, very good, 3. That's the leftover. This is what we call the remainder. The name we use in, it's called modulus, or mod. So that's another way to say remainder, but we don't say remainder in programming. We say modulus or mod. So percentage, remember that. It is for the remainder. That means we use the division, but we are interested in what is left. Like, for example, if I put 15, 2. When you divide 15 by 2, it's 7. 7 times 2, 14. So the difference, 15 and 14, that's the remainder. So that's 1. Okay? And then also we can use an operation, but be careful that we use the, whatever we use in math, which is the PEMDAS, or the order of operation, we do the same thing in computer science. So if I have, for example, 4 plus 3 times 6. So I'm not going to add 4 and 3 first. Remember, addition is the last one. So I have to multiply 18, then plus 4. That will be 12, which is different than 7 times 6, which is 42. So the good news is whatever you learned in math class is applicable in, yes, 22, Larry. So the same thing, I'm going to put minus, and then I'm going to put 13 divide, or let's say, no, 16 divided by 2. So what do you think I'm going to get here? 4. Always the addition, subtraction is the last thing. Plus, minus is the last thing. So you multiply 3 and 6, that's 18. And then you divide 16 and 2, that's 8. So now we're going to put 4 plus 18 minus 8, whatever the answer. Let's find out. So the answer is 14. Okay? So there's nothing unusual because we just follow whatever you learned in math, the order of operation. But there's something that you need to keep in mind. Like, let's say, for example, I put 4 plus 3. And then I'm going to put plus. And then I'm going to put statement like in between double quotation. 4 plus 3, the total is 4 plus 3, the total. For example, if I put the total is, what I'm going to put here is the total. Now, if I run the program, okay, 4 plus 3 is 7. So we're going to see 4 plus 3 is 7. Can you see 7 is the total? Okay, that's good. Now, what about if I put 4 plus 3 at the end? At the end. If I go right here and I put 4 plus 3, now look what's going to happen. The program will not calculate the total. What did it? It put 4 and then 3 next to each other. This is called concatenation. Because when we start with the, so if I put here, the total is, this is something just we need to be aware of. So when we start with the text is anything between double quotes, and then you put an addition, so the program gets confused. Are you trying to add or concatenate? Concatenate when you put two things next to each other, like first name and last name. So the program gets confused, and not get confused, but that's how it is understood or interpreted by the program. So it's going to put them side by side, 7. Now, what about if I don't want to put 4 and 3 next to each other? I want to calculate the total. So in this case, you have to use the parentheses. So after, this is only after, before you don't have to. So I'm going to put here the parentheses, as you can see right here, and then the program will calculate the total for me. So this is only if you have an addition after a text, after anything between double quotes, after string. This is string. But if you have it in the front, you wouldn't have a problem. So just keep that in mind. Okay? So this is just a little introduction to how to create a new program and then how to print statements. Okay? How to print statements. So next time we'll talk about data types, variables, and then how to perform arithmetic operations, and then few things that we need to be aware of. Does anybody have any questions about this? Feel free to ask any questions. Guys, I always say that in this class, a pure science class, I always say that. I said the stupid question is the one you did not ask. That's the stupid question. Is the one that you did not ask, that you just keep it for yourself. No, maybe that's not, they're gonna laugh at me. Or, oh, that's stupid question, no, I'm not supposed to say. No, anything, because sometimes that's what motivates me, because sometimes I want to talk about something and I forget, and somebody may remind me by asking questions. What about if we do this? What about if we don't? So this type of question that's going to make me remember something that I was planning to say, but I forgot, and somebody reminded me. So it helps everybody. It's a win-win situation. And then sometimes many people just say, oh, I'm glad that question was asked because it was on, I was thinking about it. I just did not have the courage to ask. So always, ask. That's how we learn. That's how we grow. That's how we get better. All right. Now, after doing this, so let me stop here and see what kind of questions you're gonna have. So I'm gonna go to Canvas. So let me share my screen so you can see what I see. Let me share my screen. So, okay. So let me see what's in the modules. Okay, of course, the first one is easy. We're just talking about the discussion, that stuff. So we're talking about this. So after I'm talking about chapter 1. So program assignment number 1. What are you supposed to do here? So there are 3 things that you need to do. So basically, using the system out print line that we just learned, you're gonna make a box like what you see, okay? And then you're gonna put some information. You don't have to put your own information, anything. You can put the same information that you have, Maria Gonzalez, or you can put like a random information. We just wanna put a box and there is contact information inside, and your initials. And then number two, basically you print this using system out print line, like I showed you. You print these four statements. Create, like what we did, this is just to test. You're gonna put create to simple, but make sure you put double quotes, surrounding every statement. And finally, number three, remember we did some calculations. You're gonna do the same thing. You're gonna put system out print line, and then you're gonna put this arithmetic operation. Now for the first one and two, let me just get you started in case you don't know how to get started. So let me share my screen. Okay, I'm sorry, let me share the other screen, the J Creator one. All right, so how do we make these boxes? It's very simple, using the same thing. So I'm gonna use, it doesn't matter which symbol you're gonna be using. So I'm gonna use, let's say, the stars. I'm gonna go stars like this. What is this? Or like the pound key or whatever. So I'm gonna do like this. See, that's it. And then I wanna make it 2 times. Because remember, I just wanna make a box inside. That's all what I need to do. So first, I'm gonna copy this 2 times. So I'm gonna copy and paste it. So that's gonna give me the top of the box, right? And then keep doing the same thing, and then I'm gonna leave some spaces and then start typing. I'm gonna go like this. Just make sure everything is aligned. So this is, I'm gonna put my name. Let's say John Travolta. And then I'm gonna make sure, look, that everything is aligned. And every time I check, I build and then run the program and see what it's gonna look like at this point. See? So I'm gonna go like this. Oh, that's what it looks like. Oh, because I've used print, I need to use print line, because remember print line, it prints and then start new line, because I forgot from the last time we left it as print. So everything should be print line. So now look at the box. So that's good start. Very good. And then I'm gonna continue the same thing. I'm gonna copy this. That's the closest one. Copy. And then paste it. And then again, make sure they're aligned. So I'm gonna delete all of this. Make sure you have only 2 stars. And then somewhere in between, you can put address. 2431, I don't know, anything, just make up stuff. And then Hammerley Boulevard. And then again, make sure they're aligned. Look, this one is not aligned. I'm gonna put print line. Now it is aligned. And then this one should be aligned as well. And then always build a run. Don't wait until the end to run the program. Always build and run. So if there's any error, any mistakes, any problems, any issues, you take care of it before the program gets bigger. Look, look, the address is leaning okay to the right. I can just move it to the, so it's kind of centered. And then always make sure it is aligned. Okay, and then again, copy and then paste and do the same thing. So is it phone number, whatever, sorry. By the way, you can use Control Z if something that happened in, just use Control Z, just like in Microsoft Word. So here, I'm just going to use my phone number. So just make up stuff, 832-123-4567. Okay, and make sure it is centered somewhere. I mean, as much as you can, it don't have to be perfect. And then you make sure on the right side, there we go. See? So far it looks fine. And then you continue. And then at the end, since the beginning and the end are the same, you can just copy that, and then you close. Once you are finished, you do like this. See, that's a box. See? So when you run the program, it's going to look like this. Now for the second one, for the initials, it's the same thing. Like let's say my initial is, let's say for example, EM. I'm going to start E. I mean, you can do it on the paper if you want to, and then try to copy this to the computer. So for example, if I have E, what I'm going to do, I'm going to start with this. So this is the starting of E, right? And then I'm going to copy this, and then, okay, and then I'm going to delete that. I'm going to leave only space because I want to make E. Okay, so maybe start this one right here, make it 3 or 4 times or something like that. I mean, as much as possible. So whatever your initials, try to make it like that. So this is right here. I'm going to do right here. And then I'm going to repeat this to make the E like the middle of the E. So copy. And then, that's something very simple. It's not complicated. It's just basically to be familiar with the program, so you feel comfortable. See that? And then maybe I copy this because that I have to repeat this. So this is for E. Now for F, something also similar and stuff like that, depending what initials you have. See that? And then maybe start another one and then close the E, depending how big you want it to make or to look like. So now, see that? That's E right there. That's going to look like E. So that's simple. It's not complicated at all. Of course, I cannot see the entire page. So let me erase this so you can see the whole thing. Everybody get this? Okay, make sure I have the. There we go. Can you see E? And then you're going to do like the next one. You're going to put like F or T, whatever you have. It's just like make sure like one line at a time. That's all what you are doing. One line at a time. Once you are done with the first line, move on to the second line, third line. Now, if you can do it on the paper, you can do it on the computer. So maybe you can do it on the paper first. Look at it and see what is the first line. What do I have to do to make the first line? So maybe you have to make like say 10 stars, leave a space, and then 6 stars. Move on to the second one, and so on. So anyway, by the end, it's just make something, even it doesn't have to be perfect. As long as it looks like your initials, then it is your initials. So I'm not going to make a big deal of that. All right, any questions about the programming assignments for this week or for the first chapter? Let me just close that. All right, any questions? Any questions about the assignment? Do you have any questions about this one, programming assignments? I'm gonna for the quiz, just basic of us, and then you have many attempts. You can answer the questions many times. It's about the chapter 1 that we went over. Then if I miss something, go back to the PowerPoint, and then I will post some videos, this video and also any other video that I have using my own voice, because I have some lectures about the basics and the concepts of Java. I can add them too in case like you want to learn more about this. So as you can see right here, quiz is just basic questions about Java, like and computer and stuff like that. It's very simple. And then, as I said, you have multiple attempts. Basically, it helps you master the skills, and then so it's just about trying. Basically, it's about the effort. Okay. I want you to be graded based on the effort you make, how much effort you make in this class. So that's why it says you just have to be yourself. Try to make the best effort in this class, and you will have no problem, succeeding and then passing this class. It's not complicated at all. I've been teaching this class, as I said, for 22 years. It's just it's simple, it's easy. I know, like the first time, if you are taking computer science for the first time, people they freak out, they get scared, but there's nothing to be, because many of my students, they never had any background in computer, and they succeeded and they excelled in this field. Some of them, they are in No, they choose computer science as their major, and they went to computer science program in UT, in Austin, in other prestigious universities. So nothing can stop you from from excelling, from doing what you want to do. Just be yourself and then do the best you can. Work very hard. Ask questions. Seek help. That's it. That's the formula. The recipe is simple. All right. Any questions? It's almost time. You have any questions? Any concerns? Any thoughts? Any ideas? All right. If you have no questions, so we're gonna stop here. Let me stop the record.